Welcome to this video. Today we'll be looking at an algorithm, the palindrome linked list algorithm. Currently we are going through the lead code patterns by Shem Prashad. The link is in the description if you want to check it out. Today, as I've said, we are going to look at the palindrome linked list, and I hope we do enjoy uh, this video. So the palindrome linked list, we see here that the question says that given the head of a single linked list, we are to return true if it is a palindrome or false if it's otherwise. So we are to either return true or false, but we are to return true if it's a palindrome or false if it's not palindrome. So for example, here we have 1, 2, 2, 1. And so this is a palindrome because whether I start from back or from front, it is the same item. But here where we have 1, 2, it is false because when we go backward, it is 2, 1, not, and coming forward is 1, 2. So we are told that there will be at least one node because the range is from 1 to, I think this is 100,000, and then the value will be between 0 and 9. Could you do it in O of n time and O of 1 space? So we are encouraged to try and solve this in an O of 1 space. So let's go to the board and see how this looks like. So here we will have our linked list. So for example, we have 1 pointing to 2, pointing to 2, pointing to 1. Now, the finding a palindrome is very simple. We could just put this into an array because the problem here is that a linked list gives us a simple challenge, a challenge, and that is that we cannot go backwards. So, but in an array we can go backwards. So if we have this into an array, we could just check from front and from back and see if it is a palindrome. So basically that would be time will be O of n, and then the space will also be O of n because we need to create an array as long as our linked list. So that will be the first approach. But we are trying to do this with a space of a constant space, that's O of 1 space. So how we could do this, it will be very important we watch the previous algorithm video where we spoke about reversing a linked list. Also, we need to use our knowledge of finding the middle because these two will be very pivotal. So if we look at this, if I make this same linked list like this, and then here I now have 1, 2, I can be at the same time moving forward from here and moving forward from here to check. But what this means is that I have reversed what was here. So what was in this second half, I have reversed it so that it now is 1, 2. So that I could now, and since I've reversed it, I could now check it going in the same direction. So from here, if I check this is 1, this is 1, I go to the next, this is 2, this is 2, and I know that's the end. So since this will be null, I know that that's the end of it, and I can now check that this was at any point were they not the same. If at any point they were not the same, I know that this is not a palindrome. So that is the idea we want to use here. So it is that we will reverse the second half and try and check if from that halfway mark it's the same thing we have from the beginning to the middle. So basically that is what we want to do. So for example, let's just have another example here. So let's say we have 1, 2, say 3, then we have 2, and we have 1. So here what we want to reverse is we want to reverse this so that we have 1, 2, 3, and then when we have reversed this, it becomes 1, 2, and we can start from here where we reversed and start from here. So we now ask this is and these are the same, yes, and then we move them, this and the pointer is now here, and we check this and these are the same, And when we know that this is the end, because when we try moving there, it's going to be null. So we know that this is a palindrome. But for example, if we have a situation that is not a palindrome, let's say we have 1, 2, 3. Let's say we have uh let's say we have one. Okay, so it should have been 2 here. Let's say we have 4 here, and then we have 1 here. So by the time when we come and reverse this part, what we have is 1 pointing to 2, pointing to 3, pointing to 1, and pointing to 4. So we'll have our pointers here and we have our pointer here. So we know that 1 is equals to 1. That's fine. So when the pointer moves again to this and this, 2 is not equals to 4. So I know that this is not a palindrome. So basically, what I want to do is I want to get the middle point. So for example, the middle point for here is going to be 2. Get that middle point and reverse it at that point. But you see, the trick here is we don't want, for example, when we have an odd number, we do not want it to pick the middle. Actually, we want it to go one step after the middle, because if it picks the middle and it reverses it, we will have a problem there. So for example, if we reverse 1, 2, and we reverse 1, 2, 3, so we see this is where our pointers will be. If we check this 1 and 1, correct. When the pointer comes here, 2 and 2, correct. The pointer will still move forward because it's not null, and this will not be 3 because this is 1, and if you say it is not palindromic, so that is not correct. So that is why we have to remove one step after the middle if it's an odd number, or if it's an even, we want to move it at the second middle. So we have worked on something like this when we talk of getting the middle, and we have also talked of done algorithm on reversing linked list. So basically, those are the two algorithms we'll be trying to apply here to achieve a constant time and space algorithm. If we reverse this linked list in place, that is an O of 1. And also, when it comes to getting the middle, it's also an O of 1. So it means that our total space will be O of 1. So let's look at this in code and just see how it comes out. So we know that, so let's just abstract this away so it's just a little bit easier for us. So let's say the list node, we want to use this to get the middle. Let's just call it get middle. And then what we have passed is the head of the node. So you remember we have the fast, which is the head, and we have the slow runner, which is also, both of them will start at the same location. So what we want to do, but you remember that because now we want to go to the next, we don't want, if it's an odd number, we don't want it to be at the middle. We want it to be the next after the middle. So that's very important to note. So while our fast.next is not equals to null, and our fast.next is also not equals to null. And this basically is because we want to get the second middle or the middle itself. So what we have here now is going to be our fast is going to be fast.next, and our slow is going to be slow.next, and then we keep going, and then we know that when we return it's going to be, what you see, because where will we stop will be, so for example, let me just go ahead to the board again. Let me just create some space here so that we could, okay. So yeah, let's say we have 1, 2, 3, let's just have 4. This should be fine. So when I have my fast and my slow here, so let's say this is the fast and this is the slow. So if I have my fast and I move 2 steps, so this is where my fast is and this is where my slow is. Now I am saying that if this is null or the next is also null, I don't want to go forward. That means I want to stop here. And when I stop here, I am saying I want to go to the next. What I am returning, if you look at the algorithm there, is that I am returning the slow dot next. So that means this is where my slow is. The next is actually going to be here, which is actually want to achieve. Now, if we also try and do this for odd numbers, so let's say 1 pointing to 2, pointing to 3, pointing to 4, and pointing to 5. Let's say we have this also. So if I have my fast pointer here and I have my slow pointer here, so my fast pointer goes 2 steps. So my fast is here, my slow is here, my fast is here again. The next is not null and the next is also not null. So my fast comes here again and my slow comes here again. So this is where my slow stops, right? Because the fast dot next and the fast dot next would definitely be null. Both of them are null, so it wouldn't even bother with that. So it means that my middle is here. But where I want to start my palindrome to reverse, because of my palindrome, is I want to start it from this second half, not from him. So that means also going to be slow dot next. So you see, in both situations, I just need to return the slow dot next. That is why we had to return the slow dot next, so that it will be where we want to start our reversal from. So what we need to work on is actually the reverse algorithm. So if you remember, reverse from middle. So we just have this, let's call it middle. And then what we want to have here, you remember we just have our previous is null, and then we will continue going this where our middle is not equals to null. So let's just have a temporary here, and then we put in what is in our middle, the next item there, what is in the middle next, we put in what is in our previous, and what is in our previous, we put in what is in our middle, and then we will just have our middle here will be what is in our temp, and so we can just return our previous. So with this now, I know that if I can get the middle, so if I can get the middle, which is just going to be get middle, I pass in my head, so I know that what I will be getting is the middle node. So to that middle node, I want to get the reversed from middle. So that will give me my reverse, from middle, and then the node I'm passing in the middle, and then what I will now have now is the pointer. This reverse from middle is going to be the pointer at the beginning of the middle. So and my head is at the beginning. So what I will just be doing is, while my reverse, I know my reverse from middle is not null. So basically what I just want to be doing is I want to be checking if the head, so if head dot the val is not equals to the reversed from middle dot var. So if it's not, then I know it's not palindromic, and if it is, then I want to go to the next. So basically just head is going to be head dot next, and then the reversed from middle will be equals to the reversed from middle next. Basically this is just what we just have, and then we know that if it gets to this point, it means it is palindromic. If after going through all the items, it finds everything to be equal to the head and the reverse middle, it finds them to always be equal at every point, then definitely it means that it is palindromic, so it returns true. Or if at any point what we have in our head moving forward is not equal to what we have our reverse from middle moving forward also, then we know definitely it's not palindromic. So if we try running this and see, okay, so okay, I didn't just variable name, so first from middle, I think. Okay, there is another one. It says line 35. So here has to be a list node. So because giving it a value, it doesn't implicitly know what it is. So because the value I'm attributing to it is a null, so any object type could be null. So, but with this, it knows that it's a list node that is actually null initially. Let's see. It's coming up. Okay, so this is fine. Let's submit and see what we if it passes. And yes, it does. So this is basically how we go about this algorithm when we are trying to find if it is a palindrome within a linked list and want to achieve this in O of 1 and complexity. As I've always said, it is important we focus and understand these easy ones because we will be building on them in when we want to solve more complex algorithms. And here we see where we applied two different previous algorithms we have done on linked lists. I hope we enjoyed this video. If you do find it helpful, I implore us to like the video, to share the video, and to subscribe if you have not subscribed. See you in the next video.